In this lecture, I'd like to talk to you about ethers and epoxides. By this time, we've gone through a lot of reactions in organic chemistry. We've seen how ethers have been made through some reactions in chapter 8 with alkenes, a little bit in chapter 11 also. And we're going to see those again, and maybe one new reaction or two new reactions in this chapter. So ethers have the formula ROR, where R is an alkyl group. Right, so ROR. Okay, these R groups could be all sorts of different things. And we'll learn how to name these as we get through the next couple of sections here. So as far as naming them, there's two ways. There's the IUPAC way, and then there's the common way. Now, in the IUPAC way, we end up calling the ether an alkoxy group. So if you had an OCH3, it would be a methoxy. If it was an CH3CH2O, it would be an ethoxy, so on and so forth. So let's do a couple of examples here together and see if we can put it all together. All right, so what about something like this? Let's take a second, jot this down. Now, what we want to do is we want to find the longest carbon chain here. So the longest carbon chain is this, right? That has 3 carbons, and this is just 1 carbon. So the longer carbon chain is your parent. So that's your parent. 3 is prop, so the parent name will be propane. So then this thing right here, this fellow, is our substituent, and that will be named as the alkoxy. So there's just 1 carbon on there, so 1 carbon is meth, right? And then we add oxy on there. And then we need to indicate here that this is at carbon number 1, right? So we want that to be at the number 1 position. If it was a bromo group, you'd call it a 1-bromo, right? So it's a 1 methoxy. So then we put all of that together, and it's simply 1 methoxy propane. Pretty simple, right? Let's do another one. So let me pull this over here. Let's squeeze in another one over here. So let's do another example. So 1, 2, 3. Come down. Let's do this. And then off of here, let's put an O. And then how about this, just to make it different from the last one. Now, what we want to do here is we want to find the longest carbon chain. So this is going to be this full guy right here. Right? Now we want to number this so that the alkene has the lowest number, because alkenes have priority over methoxy groups or alkoxy groups here, right? That's an ethoxy group. So they have priority over the alkoxy. Now, numbering from this side, you have 1, 2, 3, 4, 5, 6. So parent here is hex, right? It's not a hexane because at number 2, you have an ene. So you have to take care of that double bond there. Okay, and then at number 4, you have an ethoxy. Right, so putting those 4, well, I guess 3 elements together here, the name would be 4 ethoxy, hex, 2 ene. Now we're not done because we have some stereochemistry to address. So we have this double bond that's going to be E or Z, and then we have a chiral center here, which will be R or S. So let's take a look down here below. You could use cis or trans here, but I'm just going to stick with E or Z. So these are opposite to each other. So then we will call that E. You don't need to say it's 2 because there's only one alkene here, right? All right, let's see if we can figure out R and S. So that oxygen is going to be number 1. This side's number 2. That side's number 3. And then H is here, right? Pointing out at you, and that's going to be your number 4. So then the direction is 1, 2, 3. It moves this direction. So that direction is the S direction, but number 4 is pointing at you. So then we need to change our answer to R. So then it's an E, comma R. Right, pretty straightforward. Now, there are common names of these things too. We've talked about them before. Diethyl ether we've mentioned as a solvent more than once, and that's a common name of an ether. So we need to know how to name these things based off of the common name nomenclature rules. So to do that, we name the compounds as alkyl ethers. The current rule is to list them in alphabetical order, and that happens quite frequently. But the old rule calls for one to list the alkyl groups in order of increasing complexity. And some of these molecules with this old nomenclature are still used as names in this this day essentially because of historical reasons. Let's look at a couple examples here, guys. So I'm going to zoom in a little bit here so we can fit in a couple things. So let's see if we can put in like a little table over here. Let's look at a couple. So I want to first take a look at that diethyl ether. That's the one that we just mentioned. So let's make a little table here. Draw a little line. And then what I want to do here is make one more row down here below. And then I want to look at the IUPAC name and then the common name. All right, so the IUPAC name of diethyl ether here, so we already know that common name, right? Well, the common name of this thing would be find the longest carbon chain. It's 2, so ethane, right? And then sticking off of ethane, we don't need to number it. We have an ethoxy group. So IUPAC of this thing is ethoxyethane. Well, the common name of this is ethyl ether, but because the ethyls are the same, we just combine them together and we call it a diethyl ether. All right, let's look at another one here. Let's extend those lines out a little bit. I'm going to squeeze this in here, guys, so I'm sorry about the spacing, but I think that you can see it pretty easily. If you need to zoom in, you can zoom in. All right, so let's do IUPAC name on this. Well, what's the longest carbon chain here? To me, it looks like you got 1 carbon, 2 carbons, 3 carbons. So that's your longest carbon chain. Right, we could go the other direction too, like this, but that still gives us 3 carbons. So the parent for this, for the IUPAC, and let's just make a little note over on the side, the parent for that is propane. Right, so that's 1, 2, and then we'll just number it up here as 3. So then off of number 2, you have a methyl, and then you also have a methoxy group there too. All right, so then we put that together. The methoxy would come first. All right, we have a tie all the way up to the O versus the Y. So it's a 2 methoxy, 2 methyl, and then propane. That's the IUPAC name of this thing. All right, well, what about the common name? Okay, well, we have a methyl group here. So common name down here, and let's just block that off a little bit. That goes along with the stuff up above. Common name, we have a methyl here. And then this thing right here is a tert butyl group. So it's a T butyl group. So this uses the old system in which we rank the substituents next to that oxygen in increasing complexity. So we would start off here with methyl, and it's T butyl ether. Now, for the sake of our class, if you flip those around, I'd understand that. But this is one of those compounds that you probably ought to be familiar with. Now, 20 years ago, students knew what this was when I pointed this out, and now it's not as widely known. This has a shorter name. So MTBE. So that was used as a fuel additive for some period in time. It helped the efficiency of combustion in the engines. However, one thing that was discovered after years of using this is that it was showing up in water supplies in remote areas. So it was getting up into the air, coming down with the rain, and ending up in wells and stuff like that. So it's no longer used. All right, so last little section to look at here as far as the nomenclature goes is how to name these rings. Now, as you look through your chapter 14, focus on what I'm talking about. So there's other ways to name these that are more complex, but we just want to know what I'm showing you here, essentially. So don't stress out about some of the details in the textbook. All right, so I want to show you down below just the overall reaction, just to refresh your memory. So this is ethylene. Now, one of the reactions that we saw back in chapter 8, reactions of alkenes, is that we could add this thing called MCPBA. Remember, it's metachloroperoxybenzoic acid. And when we did that, we ended up getting this compound. And we called this an epoxide. Right? It went by another name that we pointed out back in that lecture, which was ethylene oxide. And it has one other name. It is called an oxyrain. All right, now let's take a look at how we name these things as far as being cyclic. So there's a couple basic things that you need to know here. So with 5-membered rings, we have 2 common compounds that I want you guys to be familiar with. So we have this guy here. So this is known as a furan, 5-membered ring. If we take furan and we put 4 more hydrogens across this, so put an H here, an additional H at each positions there, we get this guy, which is furan. That's THF. And then next semester, we'll see that if you have a 5-membered ring that's part of a sugar, they're called a furanose. So this is a 5-ring sugar. All right, so similar kind of pattern occurs over here with the 6-membered rings. So with 6-membered rings, you're going to have a situation that looks like this. So this is a pyran or a paran. Right, so if you put 4 hydrogens across this, you get tetrahydroparan. And then as you can imagine here, if you had a sugar that was a 6-membered ring, then you would have a paranose. The OSE means you have a carbohydrate or a sugar. Glucose, fructose, sucrose, lactose, so on and so forth. That's chapter 23 next semester. And again, so this is a 6-ring sugar. So that's the extent of the nomenclature that I want you guys to be familiar with.